Hey, here is lesson 3-4, parallel lines and the Triangle Sum Theorem. This is something new and special and very useful and helpful in the rest of your life, I promise. So, Theorem 312, the Triangle Sum Theorem. Here is the basic idea. The sum of the measures of the angles in a triangle is 180. Later on in the year, we're going to talk about other shapes like 4-sided and 5-sided and 6-sided figures and be able to have a formula to know exactly how many degrees all of those interior angles will have. But for right now, for this chapter, it's just triangles, and 180 degrees is your number. So the measure of angle A plus the measure of angle B and the measure of angle C adds up to 180 every time, no matter what the triangle. Now, here's another special thing, the triangle exterior angle theorem. The measure of each exterior angle, I'll show you what that is, of a triangle equals the sum of the two remote interiors, and I'll show you what I mean. So, in any triangle, you can extend one of the sides, and you usually see a diagram that looks like this. So, if this one, I'll copy basically this diagram here. We've got angle 1 here, angle 2 up here, and angle 3 over here. Let me name this one. I'm going to call this angle 4. Hey, look at that! What can you tell me about angle 1 and angle 4? That's right. They are supplementary. They add up to 180. So I can say measure of angle 1 and the measure of angle 4, I should have made that a plus sign, sorry, plus, equals 180. Well, that's old news, so the definition of supplementary. Well, wait a minute. What about the inside of the triangle? Well, it's like this. We know that measure of angle 1 and measure of angle 2 and the measure of angle 3 add up to 180. So here we go. Measure of angle 1 plus measure of angle 2 plus measure of angle 3. Those add up to 180. So that must mean if I have the measure of angle 1 here and it appears again down here and I'm adding something to it. Here, let's go highlighter. Here's my something. Here's my something. It must mean that since these are the same, my two somethings must be the same because they add up to the 180 both times. So here we go. That means that this measure of angle over here, measure of angle 4, has to equal this sum, this measure of angle 2 plus measure of angle 3. So that's actually what you just wrote. The measure of each exterior angle, like angle 4, equals the sum, meaning the answer to a addition question, the sum of the two remote interior. So that means, remote interior means, if this is my exterior angle out here, I am not talking about angle 1 anymore. I'm talking about the other two angles that are inside that have nothing to do with the exterior angle over here. So I think we'll be practicing identifying which are the remote interiors for each exterior angle. But let me just do the same diagram one more time. A little bit different, sorry. So, triangle.
I did it.
Here is an extended line. So let's call this 1, this is 2, this is 3, this is 4. So 4 is the exterior angle, and 4 has to equal the sum of the two remote interiors. Well, the interior angles are 1, 2, and 3. Which one am I not going to use? I'm not going to use 3 because that's directly connected to 4. The word remote makes you think way far away, right? So that means angle 4 equals the sum of angle 1 plus angle 2. So now, let's talk about classifying some triangles. The first way we can classify them is by their angles. Another way we can classify them is by their sides. And sometimes we can do both. So first, let's talk about the angles. An acute triangle has 3 acute angles. Oops. Acute angles. A right triangle has 1 right angle. An obtuse triangle has 1 obtuse angle. Oops, not plural. And an equiangular, but that one was the new one for you. Equiangular triangle has 3 congruent angles. Oops, angles. Now, that was how we name them by their angle measurements. How about by their side measurements? Well, if we have equilateral, you've heard that one before, then that has 3 congruent sides. See, I don't care about the angles anymore. Isosceles has 2 congruent sides, and scalene has 0 congruent sides. And let's keep going. The exterior angle of a polygon is defined by, just like we were talking about up here, the triangle exterior angle. This exterior angle is an angle, oops, A-N-G-L-E, formed by a side and an extension of an adjacent side. Well, what does that mean? Here's the side, here's the extension of an adjacent side. So this angle, number 1 here, would be the exterior angle. And remote interior angles, just like I mentioned above, are officially the 2 non-adjacent interior angles corresponding to each exterior angle of a triangle. So, if this is the exterior angle, then these two would be the remote interior. Just like we had parallel lines with interior angles, we're talking about the angles on the inside. Continuing on to page 58, here are some examples. So if we apply the Triangle Sum Theorem, we have this triangle here, and I see an A, I see a B, I see a C. Probably going to have to find out the values, right? We can do that. So first, we're going to find the measurement of the C angle, the degrees there, using the fact that A, C, B is a right triangle. Must mean it has that must mean that it has one right angle, and there it is, right up there at C. So from A, sorry you can't see that, let me erase that. From A to C to B, that has to be 100, A to C to B is just the angle, so that's 90. And that's the definition of a right angle. So that means that this measurement here, the little tiny c, plus the rest of this, oh, that's 70, has to add up to 90. And that's the angle addition postulate. This is like a 2-column proof, isn't it? Yay! So if I subtract 70 from both sides with this subtraction property of equality, I'm left with c equals 20. Subtract 70 from both sides to get the answer of 20. Now, if we know that that's 20, so now I've got c equal to 20. How about A? Well, we've got this little triangle right here, A, D, C. So A, down here, plus the measure of angle ADC, plus the measure of angle C, well, that has to equal 180, because that is the Triangle Sum Theorem. So I must have measure of angle ADC has to be 90, because, well, they're saying perpendicular, definition of perpendicular lines. I would have said given, because it says so, but they use it right here. So that's where we get the perpendicular lines from in this given. Then that must mean that A, which is the thing we don't know, plus ADC, which is this right angle right here, plus angle C, which we already figured out is 20, has to add up to 180. So we substituted 90 for ADC and 20 for C. So that means that A plus 110 equals 180. That was just simplifying these two terms, and there we go. Then subtract the 110 from both sides, and A has to be 70, because we subtracted 110 from both sides. Next, example 2. So let's apply the triangle exterior angle theorem. We're trying to explain what happens to the angle formed by the back of the chair and the armrest as you make a lounge chair recline more. So here's the arm of the chair, here's the back, and if we're talking about this angle here, then this whole side here would have to be the 180. So if we want this angle in here, it's the 180. Take away the x. And again here, 180. Take away this bigger angle, x. So fill in the blanks. The exterior angle and the angle formed by the back of the chair and the armrest are adjacent angles, which together form a straight angle or a straight line. Straight angle. As one measure increases, the other measure decreases. And the angle formed by the back of the chair and the armrest, the angle formed by the back of the chair and the armrest, meaning back of chair with armrest, the x that we said here, that would increase as you make the lounge chair recline more. All right, last page of notes. Critical thinking. Describe how you could use either angle CAB or angle CDB to find the value of B in example 1. Well, where's example 1? Here is the triangle from the example. And the question is, how could we have used either of these little triangles or C
I think we got that set up, right?
A B, which would have been the big one, or C D B, which is sort of the medium-sized triangle, to find the value of this guy over here. So let's do that. C A B, and we don't have to worry about the little one. So we're trying to find this angle here. Well, if we know that in the big triangle CAB, we had, and we knew that this angle in here was 90. Oops. So we got 90 here, and 90 plus A, which we figured out was 70. So these two we know, this one we don't. So we could say 90 plus 70 has to add up to 180. Subtract 160 from both sides, and B has to be 20. Or we could have done it another way. We could have used the smaller triangle, or I guess the medium-sized triangle, CDB, to do it. We know this is a 90-degree angle. This is 70. Oh, look, it's the same math, but in a different order. 70 plus 90 plus B equals 180. Subtract 160 from both sides, and B is still 20. I will let you put that in your own words right here, and we'll move on. Measure of angle 3. Oh, here's the diagram. Hey, the angle that they want is right out here. This is a remote exterior angle, so angle 3 would be the sum of the two remote interiors. So it equals 90 degrees. And now, is it true that if the two acute angles of a triangle are complementary, means add up to 90, then the triangle must be a right triangle? Well, actually, yes, because even if it were a 60-30, this angle, this remote exterior angle out here, has to be the sum of the two remote interiors. So that would have been 90. These two add together to make 90, and if this is 90, then that one has to be 90. So that is true.